friends, students, and enthusiasts. Welcome back to my channel. So as you know, in my channel, we were discussing more about basic electronics and project related videos or some learning sort of a classes where you will learn how to make project, how to learn electronics. Anyhow, so today we will be one more project we'll be discussing today, that is IoT air pollution sound monitoring system. Very simple project. You will find many of the projects like this on the web, but I have made it a little different. Why? Why different? Because the components I have used, but different sensors I have used. So, okay. So we will go for this project. First of all, working principle. So I have used MQ135 detect sensor, that is for gas, harmful gases, CO2, then NH3, smoke, these type of harmful things are detected by this. There is a sound sensor I've used, that is one small sensor comes very cheap in for your pockets also. So that is sound sensor LM393 IC based. And here, instead of using the common DST11 and 22, I've used BMP280, which measures temperature as well as pressure. It is all connected to ESP32. Display is also there. That's it. Again, the display I've used is 16x2 I2C display. Then this sends data to the web server also. That is, you can, because since it is an IoT project, it has the web servers also have added. And the final part is the output. That is, you can use buzzer, LEDs. I have used it here. So two color you can see was here, red and green. That is, red will indicate that is the threshold level is very high. That is the sound or any other pollution is more than the given values. Green is safer side. So this is the project name. All right. So let's go. What are the components? Very simple. You can see here ESP32 we have used since it is IoT project. So MQ35 gas sensor I have used. Then BMP280 temperature, you can see over here BMP280, BME280 also you can use it. The only difference is you have to change the libraries. Okay, LCD 16x2, that is I2C. Buzzer, if you want, you can use it. I have not used buzzer. I've used LEDs, red and green, register, breadboard, and jumper. These are the requirements. Next is connection, very simple. I2C connection, how it is given, it has to be connected to 3.3 volts. SD and SCL, that is connected to 21 and 22. One more thing you have to remember, BME 280, ESP32 connection, that is also the SDA is connected to 21 and 22 because both of them work on I2C. Okay. So the connection, don't worry about it because it works on I2C protocol. The address will be little different. Okay. MQ135, which works on connected to GPIO34, that is analog pin, so you don't have to worry about it. Sound sensor is also connected to GPI27. This is also analog. Okay. So output is buzzer, which is connected to 23. If you are connecting it, red LED is connected to 25 and green LED is to 33. Sorry. Required libraries to install, that is Adafruit BMP280, not BME. Please remember, and unified Adafruit libraries are used. So these are very simple connection, very easy. Let's go to the lab and I will show you give you the complete demonstration there. This is my ESP32, my gas sensor, sound sensor. This is my sound sensor, and this is BME280. So these three sensors I have used it according to, I already told you this connections are very simple. All of them you can connect to 3.3 volts. That is the supply, common supply, which can be taken from here. That is 3.3 volts. And you can see here for the output, I have used two LEDs. One now, right now, the red LED is coming, the green is the upcoming. So why? The reason is the threshold value is a 3657, that is sound value. Temperature is okay, pressure is okay. There is one more thing which you cannot see. Why? Because this is 32 character display. So one more parameter is not coming, but that parameter I will show you on other things. So this is a little different, like sound is more than the threshold. That's why it is coming. So you can see now the green light came because the sound, this thing went less than the given value. So just for this thing purpose, I'm showing you. Same thing will happen with the gas, and same thing will happen with the temperature. So whatever the threshold value you give, according to that, the things will change. So only difference is I've used I2C display over here, I2C based BMP 280. Sound sensor is analog. This is also analog. And I will show you how does the characters or how the parameters can be seen in the form of for the IoT on the web dashboard. All right. And after that, I will show you the codes part. All right, friends. So you can see here, I'll just increase the screen size. This is the temperature, IoT air and sound monitoring system. So temperature is shown, pressure is shown, air quality is shown, sound level is shown. Okay. Now you can see the sound level and the light also. When the green comes, environmental safe. When red comes, the environmental, there is a problem with the environment. Okay, this will become red. So this is IoT part, that is, you can see, this is a IoT part, that is, you can see it on the web dashboard. So this is one of the, like you can see right now, it is working on this. Now I will show you, this is a very simple project, very easy to make. You can name it by any of the thing what requires that this is required for the hospitals and sensitive places and other things. You can just write it down. Okay, so this is it will be getting refreshed every time, please remember, and you will get the complete information on your screen or on your HTTP web server. Okay, right. So we will see what are the codes now. The codes, very simple on Arduino IDE. You have to select the board, that is ESP32 board, which I have selected. Do it ESP32 development kit V1. So these are the libraries. In the beginning we have already discussed. Then you have to give your SSID password, liquid crystal display, that is, this is working on 27. Please remember this. And maybe in your case it may be a little different. Then you will have BMP 280 library also. We have taken BMP 280 library, Adafruit and unified libraries, which you can see it here also. So the pin connection which are given, and these are the important point, that at threshold level. I've only given two threshold level, that is air threshold and sound threshold. Okay. Three threshold values I have given it here. So please remember, you can increase or you can put more threshold values. According to that, you will change this thing. Okay. So this is web server, how it will be coming into the IoT, that is web server part, how it will be displayed on your screen. Like this is your web server part. And you can also, in the beginning, when you start, when you reset it hard, you will get this IP address, that is IP connected IP1, whatever the IP address is there, and temperature, pressure, air, and sound. Please remember, I already told you, you will get only 3 values over here. Why? Because we have used 16x2 LCD I2C. So only 32 character we have to adjust. That is the reason why it is not coming over. But in the serial monitor, this is my serial monitor. So you will get all the values here, parameters. And here also, that is on web dashboard, you are getting all the values. I hope you understood this. I will be sharing the codes with you. Rest of the things are very easy, and you can do it. You can name it as a whatever you want, required by your project or project guide. Right? So thanks for watching. See you next time.